Bangladesh is the land of superlatives. The highest mountain range in the world feed two of the world's largest river systems. And that landscape supports the world's most densely populated country. There have been severe earthquakes over the past several hundred years. So the same natural dynamics that have built this landscape are the same ones that present the risks.
How about if we take a piece out of this, it looks solid, or that? The purpose of our research is to understand earthquake hazard. The starting point of the geologic processes that affect Bangladesh is the collision of India with Asia. This collision started a long time ago, and it's the big main setting of the tectonic system. Now, the Dauki Fault started up much more recently and is responsible probably for one of the biggest earthquakes in the historic record in Bangladesh. But we do not have a clear description of where the fault is.
At the base. So Nana, did you notice the top of that overbank?
Many people map the Dauki Fault along the border of Bangladesh, but some of our geophysical data suggests that it's actually a blind fault, which means it's buried and doesn't reach the surface. So understanding where this fault is really important for understanding how it generates earthquakes. So a lot of what we do is hiking around, trying to find rocks that we can access. And then we take measurements using a special geologic compass so we can understand how they've been tilted. It's still coming out east-west.
And the dip is 66.
Here you have sediments that were deposited horizontal, and they've been folded and tilted, so now they're almost vertical. And you usually have faults beneath folds, so we're trying to understand those faults.
It goes up in the air, right?
It does.
The position and shape of this rock tells you how it deformed. So that's what we are after. Here I get 22 degrees to the south. So if you have a sandstone and you know that the sandstone was deposited horizontally by a river, and now you find it dipping at 60 degrees, and you know that something must have turned this thing on its side. And so if you have many such measurements, then you reconstruct what this deformation has been.
As we go to the south, we're seeing the dips increase, and the change is related to the fact that we're seeing a fold over the edge of the fault, and this helps us to figure out where the fault is lying underneath.
So yeah, this dip is 36 degrees.
It's a very interesting outcrop on the other side. We should go look.
Yeah, sure. It is very important to determine the fault location in order to assess the seismic events, because if the Dauki Fault is located 10 kilometers to the south, that means the source of the earthquakes is more close to the capital city Dhaka.
An earthquake would truly be a catastrophic event, but earthquakes can also influence how the rivers behave. So we want to understand how the river systems are potentially being influenced by the tectonic deformation. One way in which we can study that is to go to the sediment record. The way we do that is by drilling using this local drilling technique for installing drinking wells. The drill team are able to core down through anywhere from 50 to 100 meters of sediment. And we are capturing these sediments as they're extruded. The first thing we want to do is assess the relative size of the sediments, because that's telling us the strength of the water flow that transported that material. And the color tells you something about the type of environment in which the sediments accumulated. It actually is a ticker tape, a recorder of Earth's history. We know there was a major change of course in the Brahmaputra River by over 100 kilometers when it shifted from flowing through this low-lying Sylhet Basin into its modern-day course through the Jamuna Valley. Now, this subsiding Sylhet Basin should be a strong attractor for the river to want to flow into this big depression. But what we think is that there's some complex tectonic deformation that's actually preventing the river from moving through this shallow ground. And if there was an earthquake, it could force the river into that basin. And if it were to happen today, it would be a particular double whammy of having a 10-kilometer wide river change course and spread across roads, bridges, towns, and villages at a time that you would have a major earthquake.
If a large earthquake hits Bangladesh, the size of the disaster and the problems that arise to help people are going to be new. We never had 15 million people living in a city with poorly constructed buildings and a population that's growing very, very rapidly. So there is an obvious application to what we're learning here, and urgent.